Good afternoon, students. In my last video, I was explaining about Wittig-Horner reaction. In this video, I would like to explain about Spiro reaction. Spiro reaction is nothing but conversion of tosyl hydrogen of carbonyl compound into olefin in the presence of strong base is called Spiro reaction. First of all, we consider carbonyl compound and react with para-tosyl hydrazine. Then it forms tosyl hydrogen. This tosyl hydrogen react with two equivalents of base to form a olefin. N2 and tosyl hydride are byproducts. Tosyl hydrogen is prepared from para-tosyl hydrogen. This is also prepared from hydrogen. What is the molecular formula of hydrogen? NH2, NH2. In NH2, one of the hydrogen is replaced by this tosyl group. That's why it is called para-tosyl hydrogen. This para-tosyl hydrogen, this is the preparation of tosyl hydrogen and react with tosyl chloride. HCl is eliminated to form para-tosyl hydrogen. I'm going to explain this mechanism. First, carbonyl compound and react with para-tosyl hydrogen, TsNH2NH2 for our simplification. Then H2O is eliminated from these two compounds. So tosyl hydrogen is converted into tosyl hydrogen. Tosyl hydrogen is converted into tosyl hydrogen of carbonyl compound. This is called tosyl hydrogen of carbonyl compound. Then we add base. We consider 2 moles of base, whether N-butyl lithium, methyl lithium. Generally, we all are know RLI, alkyl lithium acts as a base. So in this reaction, I'm consider methyl lithium as a base. We consider 2 equivalents, 2 moles of the base. These 2 moles of the base subtract 2 hydrogens, 2 acidic hydrogens. In this molecule, this hydrogen is a more acidic nature, and also this hydrogen also more acidic nature. So these 2 hydrogens are abstract from the methyl lithium base. Then this product obtained like this. So H plus is eliminated from this carbon, then the carbon gets negative charge, and H plus is eliminated from this nitrogen, then this nitrogen gets negative charge. Partially lithium plus is attack on this C minus. Then in this tosyl, TS is eliminated and the bond polarized towards nitrogen. Then a new double bond is formed between this carbon and this carbon like this, and a new double bond is formed between these 2 nitrogen atoms. In this molecule, N2 is a more stable molecule. So the bond between this carbon and this nitrogen breaks to form N2, N triple bond N. That's why N2 is eliminated and the carbon gets partially negative charge. This molecule undergo 2 types of the reaction when we consider acidic hydrolysis. Acidic hydrolysis is nothing but addition of H plus ion. This is a alkyl halide reaction. Friedel-Crafts. This is also called Friedel-Crafts alkylation. are also called alkyl halide addition. In presence of AlCl3, it is called Friedel-Crafts alkylation, otherwise alkyl addition. So alkyl addition, this methyl group CH3 plus X minus. So the bond between this CH3X is breaks to form CH3 plus and X minus. So this carbanion, the bond is new bond is formed between this carbon and this methyl group. Finally, on acidic hydrolysis, H plus is attack on this carbanion. So we get olefin. A new double bond is formed between two carbon atoms. Finally, spiro reaction is nothing but conversion of tosyl hydrogen of carbonyl compound into olefins in the presence of base. This is resoselectivity of spiro reaction. Generally, resoselectivity is observed in unsymmetrical tosyl hydrogen carbonyl compounds. So, resoselectivity is nothing but two unequal amounts of the products is formed. One is major, another one is minor. Out of these two products, less substituted olefin is a major and kinetically controlled product. So, I'm going to explain this pyro reaction. Less substituted olefin is a major product and this reaction is called kinetically controlled reaction. Suppose we consider this is an example. This carbonyl compound and react with para tosyl hydrazine, we get tosyl hydrogen. This tosyl hydrogen and react with two equivalents of base like CH3, Li, N-butyl lithium, LDA, whatever it. In presence of solvent to form olefin. There is two possibilities of formation of olefin. One hydrogen is abstract from this nitrogen, another hydrogen is abstract from this carbon atom or this carbon atom. So there is a two possibilities of second hydrogen abstraction from carbon atom. That's why we get two products. These two products are obtained by following mechanism. So this is a mechanism of resoselectivity of pyro reaction. So first of all, consider tosyl hydrogen. This tosyl hydrogen react with the base. Suppose first hydrogen is eliminated from this nitrogen and second hydrogen is eliminated from this carbon. Then we get negative charge on this carbon. Again as usual in the above mechanism. Then the tosyl group eliminated and the double bond between this carbon and nitrogen polarized to form a new double bond between these two carbon atoms, and then N2 is eliminated. Why? Because N2 eliminated in this reaction? Because N2 is most stable compound. That's why it easily eliminated in the reaction. So after elimination of N2, we get negative charge. On acidic hydrolysis, we get this type of olefin. Suppose if we consider tosyl hydrogen, first hydrogen is eliminated from this nitrogen and second hydrogen is eliminated from this carbon. Then we get a carbanion in this carbon atom and tosyl group is eliminated and then N2 is eliminated. Then we get negative charge on this carbon atom and on acidic hydrolysis we get this product. Out of these two products, which is major, which is minor is based on Resoselectivity of spiroreaction. Resoselectivity of spiroreaction explains less substituted product has a major product and more substituted product has a minor product. So to observe this double bond, this double bond is substituted. This side there is a two substituents, this side there is one substituent. So I'm going to explain this resoselectivity. Now this double bond has a two substituents, one is from this side, one is from that side. This double bond has a three substituents and this double bond has a two substituents. Out of these two, this is less substituted product, that's why it is a major product. This is the resoselectivity of spiroreaction. Next, these are some of the applications of spiroreaction. First, we consider tosyl hydrogen carbonyl compound. In some of the cases, we consider carbonyl compound and react with para tosyl hydrogen. Then we get a tosyl hydrogen of carbonyl compound, and then it react with base, two equivalents of the base, and then it undergo acidic hydrolysis or alkyl halide addition. Out of these two products, which is major, which is minor, is depends on resoselectivity of spiroreaction. Less substituted product as a major product. So I'm going to explain this mechanism. One hydrogen is eliminated from this nitrogen side, and second hydrogen is eliminated or abstracted by base from this carbon atom or this carbon atom. This carbon atom, both these two carbons are adjacent to this nitrogen, I mean this carbon, this nitrogen attached carbon. That's why there is two possibilities, one is this carbon, another one is this carbon. So we get two products. Out of these two, which is minor product, major product, and this is a minor product, because this has two substituents and this has three substituents. So less substituted olefin as a major product. Second example, this is also carbonyl compound and react with para tosyl hydrogen. Then we get tosyl hydrogen of carbonyl compound. This tosyl hydrogen of carbonyl compound react with base to form a olefin. React with base to form a olefin. Here also there is two possibilities. One is from this carbon and another from this carbon. Out of these two, this side double bond is a less substituted side double bond. That's why it is formed as a major. There is a methyl group also present in this carbon. There is a methyl group because there is no methyl group. Suppose if we react with alkyl halide, then we get a methyl group from this carbon. But here we use acidic hydrolysis, that's why there is no methyl group, there is a hydrogen present in this carbon. Next, now I would like to explain about third application. Here also we consider tosyl hydrogen of carbonyl compound. This react with the base and finally undergo acidic hydrolysis. We get two products. Out of these two, which is major, another one is a minor, because this is a less substituted olefin, this is a more substituted olefin. Okay, this is about spiroreaction.